A few years ago, we started the Urban Center for Computation and Data at the Computation Institute, which is joint between the University of Chicago and Argonne National Laboratory. Because the data that's available to cities today is fundamentally different than what was available even 10 years ago. So the question there becomes, are there services and technologies that we can embed within cities that make them more livable, more friendly, even safer? To pursue these and other scientific questions about cities, we're working with the City of Chicago to deploy a platform that will allow us to collect data for various kinds of scientific inquiries into sustainability of cities, into the operation of cities. For example, how would city life be safer? How would it be easier to navigate a city if on every street corner there was a device that could tell you something about how the city is at the moment? One example would be, imagine that you don't know the City of Chicago, but you need to walk 8 or 10 blocks. It's 10 p.m., you're by yourself. You'd want to walk on the streets that have the most foot traffic on them. With these sensors on street corners, we can count the number of pedestrians that are going by and give you a map of the city on your smartphone that says, here's a route through the city where there are the most people on the street right now, the safest route at 10 p.m. The volume of the data, the diversity of the data that cities have at their disposal to make decisions makes for a possibility of making policy that's not reactive, but is actually proactive.
Thank you. I feel like a rock star. I have one of those microphones that go around you can't see it, but go around your ear. So if I start to stumble for something that you can't see, it's because my microphone fell off. Never had one of these before. We've been, for the last couple years here at Argonne and the University of Chicago, we've been watching the way that urbanization is happening around the world and just thinking over the next several decades. And what I want to do tonight is give you some background on why it is that we here at Argonne and at the University of Chicago think cities are interesting things to look at from a scientific point of view. What are some of the scientific questions that we're asking about cities and why those questions are relevant? And then tell you some things about the tools and the methods that we as computer scientists have been developing here in order to help social scientists, economists, policy makers, or climate scientists, people that study water, to help them do their science in looking at cities. So I like to say when I meet with a different scientist, whether it's a climate scientist or a biologist or a social scientist, I'm not a social scientist, I'm a computer scientist. But I think that working together, I can give you some tools that will help you do your job better. And so I'd like to give you, through the course of the next few minutes, some examples of what some of those tools are. Now, I'll just start by pointing out where we are. How many people have never been to Argonne before? So a fair number of you have never been here. So there are a couple thousand people that work here. As you probably figured out, we're right here in the advanced photon source. This building that we're connected to is one of the world's brightest X-ray sources, and people from around the world use that to do science in various fields, from material sciences to biology to even pharmacology. Some of our newer buildings, this one you might have seen as you came in, unless it was dark. This one here is the Theory and Computation building, and there's a new building here since this building was this picture was taken. And here's where we house one of the 5 fastest supercomputers in the world. And this is where all the people that work with computing, that's where we work. So my office is somewhere right around in there. We put everybody at the laboratory that did anything related to computing in one place so that we could get this cross-fertilization between the different fields that use computing and computer scientists that develop computing systems. So one way to think about the laboratory is we run national and, in fact, international instruments to do the kind of science that you couldn't do in the laboratory of, say, a university or a small company. And the supercomputer that's The supercomputer that's in that building that used to be right there before I changed the slide, that one of the world's 5 fastest machines, that's used by scientists all around the world, just as the advanced photon source is used, based on peer review. And so that's one way to think about the laboratory. Another way to think about the laboratory is that we look a lot like a university, but except in the summertime, without classrooms and students. And so if you were to go through the divisions that are here at Argonne, biological sciences, climate, chemistry, material science, physics, computer science, mathematics, you would find this looks a lot like a university, again, except without the classrooms and students. And in the summer, we have several hundred students that come here. What I didn't list in that list of things that we do here in Argonne are other things you would find at a university that you don't find here. We don't have a social science department, don't have a public policy department, we don't have a finance department or an economics department. Now, as it turns out, just up the street at the University of Chicago are some of the best programs in those areas. So when we think about studying cities, we have to think in terms of not just the engineering and the physical sciences of cities, but the purpose of cities, which is people and people doing things economically and socially. And when we look at cities, we want to look at those things together. So having a center like the Urban Center for Computation and Data that straddles these two institutions gives us a real advantage when it comes to being able to tackle some really thorny, hard problems of cities, or to take advantage of some exciting opportunities that have to do with cities. So I feel, really excited about being exactly where I am and where we are at these two institutions and studying urbanization and urban processes. It's like if you were to design a place to do that, it would look just like this place here or these two places here. So thinking in terms of cities and climate or energy, natural resources like water, climate change and emissions from cities, these are things that we do here at the Department of Energy Laboratory. And if you think about urbanization, this is a picture from 1980, a Landsat image. So red is vegetation and white is things like concrete. And this is 25 years later. This is 2005. About 40 million people live in this area. And so you can see visibly the impact of urbanization on the surface of the planet. And China, I don't need to read these numbers to you, but China is investing just in the Pearl River Delta here, and this is Guangzhou. Right in here is Guangzhou, China, one of the larger cities, but 40 million here. China's investing something like $300 billion over the next decade building out infrastructure. Now, if they build that infrastructure in a way that optimizes transportation or that optimizes the energy efficiency of buildings, then the impact of that 40 million person city on the planet can be very different than if they build it with 20th century principles of how cities are built. So over the next several decades, as these kind of cities are built, we have an opportunity to understand cities in a way that our predecessors haven't been able to understand cities. And then we have the opportunity to put that understanding of cities into practice to make a real impact on this planet. Because over the next 30 years, more new building space, more new floor space and buildings will be constructed around the world than currently exists. That means, for you guys who are in high school or undergraduates, that means that if you choose to go into almost any area of science that I mentioned before, there's an interesting set of research questions that has to do with cities where you can have an impact on future generations. Now, cities are also where people live. And I want to illustrate with this map behind me here a couple of things about cities. One is, this is a life expectancy across the city of Chicago. If you live in a red area versus a person that lives in a light yellow area, then chances are your life is about 14 years shorter than the person that lives in the yellow area. Now, why is that? We don't really know. And so when we think about cities and climate and emissions and natural resources and transportation, a big part of that equation is can we make cities work for people? The other thing I'd like to illustrate on this is that we have some data that we can trust in a sort of deep way that's measured, and we have other data that's demographic or that's collected not with an electronic sensor but with a survey, or it's a set of statistics. We have to be really careful how we treat those different kinds of data. And I'll illustrate that here to say, I showed this to some people from the community, and there were realtors there. And this one realtor said, I know this area right here where it's dark red, and nobody lives there. It's like factories or something that live there. And so what she was pointing out is that it's good to get a qualitative view here that there are differences in equity and lifespan across the city, but you also have to look at the data and go right down onto the ground and say, let's validate this data. Is this data telling us what we think it's telling us? So, but those two aspects of cities, on the one hand, how are cities going to impact the globe? And on the other hand, how is that urbanization going to impact people that live in the cities, are what motivate us here to do this work in computation in data that's related to urbanization. As we set up this new center, the first question you have to answer is, what's the new center going to do? What kind of questions or challenges will this new center try to address? And over the last 2 years or so, as we've grappled with that mission of the center, the research agenda for the center, several things sort of popped out at me and others that I've been working with about a way to approach thinking about cities and science. So first is what you saw on that slide with the two pictures of the Pearl River Delta, where at the bottom it said environment, infrastructure, and people. Almost every hard problem that has to do with cities, whether it's a poverty issue or a flooding issue, almost every challenge that a city has can be traced back to an imbalance between these three things. Or put a different way, if we focus on trying to build or improve a city or operate a city, and then we just focus on one of these three verticals, but not looking across at the others, we're almost guaranteed to do something that will improve infrastructure but hurt people, or improve things for people but maybe hurt the environment. So when we think about cities, the first thing is to think we have to look across disciplines at these challenges and these opportunities, and not just within our chosen discipline of physics or chemistry or social sciences or economics. The other observation that we began to make is that there are three types of decisions or outcomes that happen as you're studying cities and as cities operate and grow. And those, you can think of those in terms of different time scales. Certain decisions, policies, or designs for cities don't have a visible impact until maybe 15 or 20 years down the road. So you can build a highway through a city or around a city, and you won't know until 10 or 15 years later whether that was the right decision or not. You kind of hope it was, and maybe you used the best science that you have at the time to make that decision. But by the time you know whether that was the right decision or not, it's usually too late to reverse it. And we've seen that in cities around the globe. We've seen the impact, for example, of the Dan Ryan going through the south side of Chicago and ripping neighborhoods apart. So some of the decisions and the things that we want to focus on unfold over years and decades. Others, and actually in terms of the work that we're doing, most of the work we're doing is right in here with some interesting things up here and down here I'll talk about. And that is cities have to make decisions that have consequences that unfold over days or weeks or even hours. And those decisions might be anything from approving a liquor license on this corner to deciding on how to time lights as you drive through the city, or how much to charge for tolls or things like that. And so I'll talk a lot this evening about some of the data possibilities with data in this section right here. And then there are aspects of cities that unfold over very short time scales. You drive down the road, and a mile ahead of you there's a crash at an intersection, and a few minutes later you're stopped because the traffic, that accident has sent a shockwave of congestion out for a mile in every direction. And now what was going to be a 20-minute drive is an hour drive. Well, are there ways that cities can manage traffic, for example, so that they're more resilient against common things that happen like car accidents? And so I'll talk this evening also about some of the things we're doing down in this area here, helping to support decisions that have to do with those fast-moving things, but also thinking about some possibilities for how you might interact with other people or with the city if there's technology embedded right in the built environment. So tonight I want to give you just a couple of examples of computational simulations to look out into the future about cities, about data analytics to help us move, as the guy said on the video, from reactive to proactive policy, and then some of the things we're doing with embedding sensors and computing within the built environment. Okay? So I'll start right here. In the developed world, in Europe and the US, for example, it's really rare to see a real estate development that's larger than about 30 acres. In fact, most of the industry that develops real estate and designs buildings and campuses, their whole industry is tuned to a single building or maybe 20 buildings. And yet in China, they're building cities in hundreds of acres at a time and hundreds of buildings at a time. And so even the best urban designers in the US, who are also designing cities for China, have said to us, we feel pretty good about how we can design a single building or a set of buildings, but when it comes to 500 buildings, our tools don't scale. Our process doesn't scale for planning that way. If it's a single building, I can go, well, I need a grocery store down here because there's going to be more, it's going to affect the schools this way, and we'll need an exit off the interstate or something like that, or we'll have to turn the street from two-way into one-way. And in their heads, the urban designer can sort of factor in 1 or 2 or maybe 10 buildings. But nobody can factor in the impact of 500 buildings in their head. So can we use computational science, computational simulation models to give these designers better tools for doing what they're doing? Now, this is Chicago Lakeside. You might have figured out by now, this is just south of the city. Here's the city of Chicago right here, University of Chicago right in here. That's about 10 miles south of the Loop. This is a 600-acre plot of land that used to be the U.S. Steel plant. And there's now a plan to make a second downtown there over the next 20 years or so. So we began to interact with the developers, McCaffrey Interests, with the architects, Skidmore, Owings & Merrill, to understand their process of designing something like this, to see if there was anything we could do from a science point of view to help them reach their goals. Why? Because we wanted them to be successful in their business? Not really. I mean, it'd be great if they are, but because of what I said before, if they make a mistake here, we won't know about it until it's too late. So it behooves all of us to help them make the right decisions on planning this. So they had a couple of goals for this site. One was it would be a walkable community. You wouldn't have to own a car if you live there. Okay, so there's some transportation work that needs to be done. Another was that unlike the rest of the city of Chicago, when it rains, the stormwater would be filtered and then it would go back into Lake Michigan. As you probably know, 100 years ago or so, Chicago reversed the flow of the river so that it flows out of Lake Michigan instead of into Lake Michigan. That's why I have to go through a lock when you come out of the river there. This Lake Michigan is part of the Great Lakes system. It's 20% of the world's fresh water supply. So if they don't get it right, and that stormwater goes in and washes all the oil and the toxins off the road into Lake Michigan, well, that's a pretty bad mistake. So a third goal that they had was to use renewable energy at the site. Instead of coal-fired or nuclear, let's use renewable, windmills and solar and all that stuff. So we said, oh, well, we're an energy laboratory. Let's think about that one. How much energy do you need? And they said, well, we have a spreadsheet, and we think about 6 megawatts in year 1 and maybe 40 in year 50. And we said, well, where'd you get those numbers? And they said, well, we think it's right. We kind of educated guess. And then they had a straight line projection between those, like energy is going to grow linearly throughout that 50-year period of time. Well, that was the best they could do with a spreadsheet. And so we said, we have models where we can take a building and we can add weather data and data about that building, how efficient it is, how far apart the windows are, thick pane glass, how tall the building is, what it's used for. And we have computational models where we can plug those numbers in and tell you how much energy that building will use over a period of time, a year, 10 years, or what have you, based on weather and things like that. So why don't we try to plug in those scientific models for building energy behind an urban design tool? I think Bo Rod is here, and some others on that team are here that helped us do that. So we put a team together. We put Bo's from the School of the Art Institute of Chicago. He knows architecture technology. We work with Skidmore, Owings & Merrill. They're urban designers. We brought in energy experts here from Argonne, Leah Gazowski and some others here. There's a poster about this out there. And we said, let's give the designers a tool. This is just showing you the scale if I overlay Lakeside on the loop. Right, so that's how big we're talking about, 500 buildings. So this map on the left here is from Skidmore, Owings & Merrill, and it's color-coded by zoning, which means in some cases the color means residential, other color would mean commercial, another color would be retail, another color would be light industry. So this is a conceptual plan for the site. It's laid out according to the way that the site will be used in terms of zoning. And then in the fine print that I don't think you can read, no, you probably can't because I can't read it, are projected dates for that part of the development to be built out over a period of 20 years. So we said, let's give the urban designers a couple of knobs to turn and then see what the effect of turning those knobs is on the energy demand of this site over a couple of decades. So we'll use weather data from history from the last 25 years or so, and we'll pretend like the weather's going to be the same over the next 25 years. And then we'll let them click on a building or a set of buildings and change the zoning or change when it's going to be built or the phase out of the site. And then we'll rerun those models and give them a sense for how sensitive their energy demand is going to be to those decisions that they're making. And if they really want to use renewable energy, then depending on how much they can provide, they want to make sure that this curve over 50 years stays below the amount of energy they can provide with renewable energy, unless they want to not use renewable energy. And then we added something else with some of our folks here that do climate, and we said, we know the climate's changing. We think that we'll get around the same amount of rainfall per year, but we'll get it in concentrated storms. So we might get 5 inches of rain every spring, but instead of 5 1-inch rainfalls, we might get 2 2.5-inch rainfalls. So we know that some of those characteristics of rain are changing. This year we're going to have another Arctic vortex, so it's going to be a cold winter. So we said, why don't we take the historic weather, which is 23 years of every January, every February, every month, and shuffle those months around to change what the future weather might be like. Now, I'm just purely guessing what the weather might be like because we don't have a crystal ball, but it then allowed us to say, if the climate changes in this way over the next 50 years, then your energy demand is going to look like this. We found, Bo can correct me later since he doesn't have a microphone, if I'm wrong, but I think we found a 20% difference from one year to another, from the coldest winter to the, is that about right? Was it 20%? So in the coldest January versus the warmest January, your energy demand changes by around 20%. So you do want to sort of figure out what are the sensitivities to climate of these designs as well. The next step on this project is to bring in transportation, and this is a view of the interface to this piece of software from a web browser. All right, so that's using computational models to anticipate the impact of urban design over a long period of time. Now I want to talk about something that's happening that's really new in about the last 5 years. Cities around the world, and Chicago is, I don't say this just because I'm from Chicago, I probably would if because I'm from Chicago, but we are actually one of the leading cities for publishing data. And by that I mean the city has taken data about its operation, things like food safety inspections, 311 calls. Everyone know what a 311 call is? Anyone not know what a 311 call is? 311, so if there's an escaped tiger in your yard, you call 911. If there's an escaped llama in your yard, you'd call 311. It's non-emergency 911, right? So you report things like graffiti or excessive noise or garbage dumped on the street light outage. There's 250 different kinds of 311 calls. So many of those are out here, about 700 data sets out in this portal, this website, and dozens of cities, actually by now probably over 100 cities in the U.S., have portals that look just like this. And there are a lot of things you can do with that sort of data. These are some examples of what people have done with City of Chicago data to try to better understand how the city works. Here's a map of zoning, so you can get from this database the zoning map for the city, and here's the map of zoning. This down here, apologize because it's a little dark, this is color-coded all the buildings, 840,000 buildings in Chicago, although we've zoomed in on a place here, and they're color-coded by the footprint, how big the building is in terms of its footprint. Now this one over here, there's a movie, and I took the movies out because they were blinking and stuff, but all of the city assets, the buses, the garbage trucks, the snowplows, have GPS, the global positioning system, on them, and every 20 seconds they report back to the city where they are, what direction they're going in, and how fast they're going. So when you look at if you ever look at the traffic map for the downtown Chicago area, and there's like red for congestion and yellow for not too good and green for good, the way that they get that data is not from sensors on the street, but from the buses, where they say, we're going to say however the buses are moving is sort of a proxy for the way the rest of traffic is moving, because we're tracking the buses. This is a really neat video from January, a couple years ago, 2012, during a snowstorm, and these red dots are snowplows as they go around the city. So it makes for an interesting video, but it also means that you have the data for how those snowplows moved as they went through the city. And you can ask questions. If you're a mathematician, you can say, is there a better algorithm for clearing the streets in Chicago? Better, which would mean they drive fewer miles and use fewer gallons of fuel and emit less greenhouse gases. And you can actually start to ask those kind of questions because that data is available. Now, there's other kinds of things you can do with data about the city that have more of a flavor of not just understanding it, but trying to optimize the decisions that you're making. I want to give you a couple of examples from a student program that we've run the last 2 summers called Data Science for Social Good. Undergraduate and graduate students come to Chicago for 12 weeks. They do projects with not-for-profits and governments, so school districts and Chicago Transit Authority, in this case, the Cook County Land Bank. Cook County Land Bank has a set of funds, and their job is to invest those funds in vacant properties around Cook County. You can see there are lots to choose from here, 120,000 vacant properties after this housing crisis. And their job is to decide where to invest that money in buying vacant homes or buildings and either raising them, tearing them down, or refurbishing and renting them out, and spending that money in the way that has the best positive impact on the city. So that's a pretty hard problem because you don't have enough money to buy 120,000, so how do you choose? Well, we had our students look at lots of different data that would give you some indication of the impact of a vacant property on the properties around it, on the neighborhood. And some of the things they looked at here, they used data from real estate transactions, they used data from the City of Chicago data portal, they used data from the Census Bureau that said things that had data about not individuals, it's all in chunks. So this block of 100 people, you don't know, it's an average across those. And then they gave the Cook County Land Bank a tool that would let them investigate for an individual property what would be the impact of buying that property and refurbishing it. One thing they found, which was sort of interesting, is that if your property is within 1/8 of a mile of a vacant property, the impact of that vacant property on your property value is about 2%. So if you're in part of the city sort of down here, your property might actually have almost a negative value. So it might be a liability. And there's a lot of really exciting things I wish I could talk about here with some of the South Side of Chicago and properties, one of which I'll say that using some of these data tools, the neighborhood of Englewood worked with the city on a policy that allows a homeowner in Englewood to buy any of the properties adjacent to them or across the street for $1. So this is a way for the city to allow the residents to take responsibility and then legal responsibility for the vacant properties around them. So there are ways that you can use this data to actually help people on the day-to-day basis in their neighborhoods. Now this is the if you were at the data science computer science workshop, this is how the students summarized their project here. This is the first group of students. This was funded by Eric Schmidt, who's the chairman of Google, but he didn't use Google money. He wrote his own money, his own check. And he funded the 36 students in 2013 and 48 this year, the summer that just ended, and we think it'll be an ongoing program. What it does is it takes these students, they come from math and statistics, social sciences and economics, computer science, and they don't just learn how to do data mining or machine learning or these algorithms that we use to draw information out of data. They learn, how do I work, the 3 students that worked with the Cook County Land Bank had to go over, meet the people at the Cook County Land Bank, try to understand what is it that you're trying to accomplish, and then how might the data that we have or you have help you accomplish that goal. And then go back and translate that into, it's like a word problem in math, right? Translate that into a data science project that would use specific software and specific algorithms, and then give back to that organization something that would be useful to that organization, as this group did. The group that worked with the Chicago Transit Authority gave the CTA a tool that allowed them to look at the impact on crowding if they were to make changes to a bus line. So, for example, it's really crowded during rush hour on bus number 27. So what should the CTA do? One thing they could do is they could add a bus in the schedule, so more buses. They could double the length of a bus, which is sort of like more buses. But their way of doing that would be to make those kind of changes, and then they would have to collect data for 3 months, and then they would know if that change helped. That means they can do 4 tries in 1 year, 4 attempts to make things better. It takes a long time. You can ask only one question every 3 months to get it right. So our students put together a very quick tool that they could explore different interventions like that and then look at, from a computer simulation, how that would affect the crowding on the buses. And that way, the CTA could look through lots of possibilities, and they're still going to do one every 3 months implementing it and measuring it, but it means that those 4 attempts they can make per year have been vetted through lots of possibilities, so they can try the things that are most likely to work. Now, if you talk to people in cities, and at the end I've got a slide that shows all the cities that we actually have active projects with, these are the kind of things that they would like to learn from their data. And Rahm Emanuel here in Chicago has actually said, as I said in the video, we don't want to just react to problems. We want to see that a problem is coming and do something about it before it's much harder to solve the problem. And so these are some of the things that as we started working with the chief information officer for the city of Chicago a couple years ago, we just kept track of this is the wish list from one chief information officer of one city for what they would like to learn from their data. And some of these, as I mentioned before, to go from reactive to proactive means that you have to use this data to make predictions. And to the degree that you understand what causes something to happen, you can build an algorithm that predicts that based on what are called leading indicators. To the degree that you understand what causes something to happen is the key point there. There's a lot of things we don't really understand why they happen, so it's difficult to build a predictive algorithm for that. And this is really at the heart of some of the work that we're doing with economists and social scientists, is to understand what are leading indicators to neighborhood decline. What are leading indicators to violent crime in a neighborhood? Does weather really impact violent crime? If you talk to a police officer, they will say, the first warm weekend in the spring, we will have a bunch of shootings in one of these 12 neighborhoods. We don't know which one, and it won't be two, it'll be one, but one of them will pop, they say. But they don't know why. And maybe it's not the weather at all. Maybe the weather is telling them something indirect about what's causing that. Nevertheless, there are some things that we do understand and that we can predict. And so these are three examples that Tom Schenk, who's the chief data officer analyst for the director of data analytics for the city, these are projects that are actually doing. And these are three things that we have a pretty good idea of what leading indicators are, especially with rats. I mean, all of us could sort of come up with a list of what would be leading indicators for rats. Food supply, quiet place where nobody bothers them, moist conditions, a good place to hide, etc. And that's because we sort of understand what causes rats to pop up. So it turns out there are about 50 different 311 type calls, 50 different leading indicators that can be combined algorithmically, mathematically, to give you a prediction of where rats are likely to break out in the next 7 days or so. Now, they did this test with the Rat Patrol. They're actually called the Rat Patrol. They go out every day with traps and baits, and they have been going out with a list that is all the calls that they got the week before reporting rat infestation. So they would take all those addresses, and they would go out and they would put baits and traps and stuff. And they replaced that list with one that came from this predictive algorithm, and then they did this double-blind study and they tried to figure out, and it turned out that this double-blind algorithm was actually a little bit better than at predicting rat infestation than just waiting for someone to report it. And it's way better because that means you can do something about it before somebody is bothered enough to call 311. Now, these other ones are, I'd say we're at the exploratory stage where we're looking for what are clearly correlations, things that happen at the same time typically, but we don't necessarily know whether this thing causes this thing, causation. Nevertheless, it looks like these factors have an impact on, whether or not a store will be selling illegal cigarettes without the stamp and the city tax on it. So one thing I'll just point out that's sort of interesting is why would it be that Tom's Market or Charlie's drugstore would be more likely to sell black market cigarettes than Walgreens or Sunrise, Quick Mart? It's probably not the name. In fact, we're pretty sure it's not the name, but maybe this is an example of a proxy for something else. Because at Charlie's Market, the corporate oversight is like Charlie and his wife, right? If it's Walgreens, there's this huge corporate oversight that says there's probably not going to be much breaking the law here. The stakes are much higher for a chain of stores. So it's an example where we see this correlation, but it's really telling us something indirect about that. And then food safety inspections as well. Why would you want to do this, to optimize where you send your inspectors? Because the point of inspecting restaurants or looking for fire violations in buildings, the point is not to collect the fine, although that's always useful in a budget that's always tight. The point is to fix problems that are dangerous. So you have a fixed number of inspectors. You want to send them to the places that are most likely to have violations because violations mean public safety is at risk. And so here in Chicago, looking at food safety inspections, some of the factors that go into how there are three. There's like low, medium, and high risk restaurants. Out there on the portal, by the way, before you go out for dinner, you could actually check to see if your restaurant is low or high risk. So that's how they schedule their inspectors to go out. When we started working with social scientists at UChicago or Harvard or other places and economists, we noticed that we computer scientists were very aware of what data is available. We had a good idea of what tools to use to analyze the data. And then I would talk to people at UChicago who study cities, and they were not aware that this data was even out there. And so I was talking to one guy one time, and I said, yeah, it'd be cool if you could figure out, if you put a bus rapid transit down Ashland, what would be the economic impact before and after that? So you could go and you could get tax receipts, in other words, the business volume before and after, and you could do that comparison. And this sort of rock star social scientist looks at me and goes, you mean there's I could look at that data. You didn't even know it was there. And then the second is that if they did know it was there, they wouldn't know what to do with it because they're not data scientists. So a few of us set out about a year ago. This is Brett Goldstein here, the former CIO of the city of Chicago. So Brett and I started talking about, could we make an interface to all this open data, these portals that all these cities have, that would not require you to be a data scientist before you could ask a research question of that data. Translation, not only would that make it easier for a social scientist or an economist to start exploring data in the city, but it would mean an ordinary person on the street, a carpenter, an AV expert, or an accountant could start looking at their neighborhood and trying to figure out what the data might tell them, maybe even ask some questions about that data that would help inform the city about something about their neighborhood. So we built this thing, it's called Plenario, and we released it about a month ago. And what it does is it allows you to select an area on the map, and then you specify a start and an end date. In this case here, I'm interested in what data is available for this area on the map, and I've just used the whole map rather than draw an area. I could draw the Chicago Marathon route, and I can ask a question about that. But I want to know for this whole map, what data is available that I could look at between February 24th and August 23rd this year. And I would like the numbers aggregated by week. So if it's a daily report, I just want to add it up a weekly report. And then I get this long list, of course, it's cut off here. It's about 50 data sets in there so far from New York, Chicago, San Francisco, and Boston of the data that's available to me. So I go, okay, so I want to look at abandoned vehicles. So I click here, and I get this nice map that says each one of these squares is 500 meters, and the color code says how many abandoned vehicles in that period of time were reported in that square. And I might want to use this data to go and do a research problem with data science algorithms and tools. And so I can click here and just download the data and leave this tool and then go do my science. Or I can explore a little bit further. I can know, for example, not only what data is available for a larger period of time if I wanted to expand from these 6 or 8 months, but I can then click in there and find out the fields in that data. What does this database hold? It doesn't just have the location and time of the abandoned vehicle, but it might have some information about the type of vehicle. So I want to know what's inside that data. And I want to zoom in and look at not 500 meters, but down to 100 meters, so I can zoom in on the spatial scale and start to look, and I can, as I go forward, just zoom into an individual neighborhood. And what I just showed you there, without a tool like this, would have taken a couple of months of work to pull that data together and merge it together, because all these different data sources, even though they come from one data portal, they have different formats, they have different ways that they lay the city out, different boundaries, different time spans and things like that. So as I mentioned, we have data from these 4 cities. We've been contacted by another 3 or 4 cities, 3 cities in the last week, saying we would like this Plenario to be running in our city. We already have been working for the last 3 months with San Francisco to give them a version of this software. It runs on commercial cloud services. That means that we didn't have to buy any hardware. We just essentially lease the hardware, lease the servers from Amazon in this case, and then we pay. It's a pay-as-you-go. So that means another city doesn't have to go out and find out what kind of computers we bought, connect them, buy them, etc. They can just go to Amazon, or if this gets ported to another service, go to that other service. But now, go to Amazon and say, I want a copy of Plenario for my city. They click a button and boom, they've got it. And then they can start putting their data in. We've worked with San Francisco to do this separate from our version because they have data that they don't want to be public. They don't want it to be, for safety reasons or privacy reasons, they don't want it to be public. So we went and worked with San Francisco to give them their own version. But these 4 illustrate some of the things that you can do with a tool like this. And by the way, I'm not selling it because it's not for sale. It's open source. It's free. The things that you can do with a tool like this that literally save weeks or months of time of gathering data, finding data, pulling it together, and merging it together so that you can ask more questions more quickly, just like the CTA. So here we asked not just where are the car accidents in New York City in a particular period of time, but just show us the ones that were during a rainstorm. So we had to pull in weather data and car accident data, and that would have been hard to do, but we already had the data in there, and so we were able to ask that question. Here are snow-related 311 calls during a particular storm in Boston. These are all 311 calls for San Francisco. And here, I was just at a conference right here at the Hyatt, and so I showed people all the density of restaurants in Chicago that were low risk of food poisoning, right? So I said, basically, you know, you're safe to go out. It's a safe city. You can go out and eat and not worry about food poisoning. Now I want to give you two examples of some of the people that we're working with outside of UChicago and Argonne. One is a group at the Santa Fe Institute who have done some really interesting work looking at the 400 what are called major statistical areas, or MSAs. So an MSA is like a cluster of cities or a large city. So every city and town in the U.S. is in one of these 400. So the MSA for Chicago includes like Gary and Naperville, and it's actually called Gary, Naperville, Chicago MSA. So they looked at all sorts of data from the 400 across the U.S., and they found some interesting things, one of which, just to illustrate, is that as the population goes up in a, let's say, urban area, city, MSA, as the population goes up, the wages per person also goes up. So each of these are one of the 400 areas, and you plot them, you get this really, you draw this red straight line over it because there seems to be a correlation between the size of a city and the income, the per capita income in that city. Well, it's a fair question to ask why, and we don't know. And there are lots of other, something like 30 other variables that have to do with cities that they looked at, from the number of AIDS cases to the number of miles of roads, that all exhibited this linear function where they grew in proportion to the population of the city. Now, some other, I think, it's kind of fun research back in the 70s that you might, so my dad worked in New York City when I was younger, and so I can verify this is true. The larger the city, the faster people walk. And somebody in the 70s graphed it out, and they said, yep, it's true. There's a 6 million person city. This is how fast people walk, and, you know, this is probably New York City here, and maybe Chicago's down here. So you actually see these interesting things about cities if you look at the data statistically. And what's also interesting about it is that cities seem to grow differently than biology does. You often hear people talk about the metabolism of the city or thinking of the city as an organism, and that's good, but what happens with mammals, if you go from, say, mice to dogs to humans to cows to elephants, is the more mass of the animal, the slower the heart rate. And you get a curve that's in the opposite direction here with a negative slope as the mass increases for an organism. So it's interesting that although we think of cities as organisms, they don't really behave exactly like organisms in every way. But there may be something that we can learn from this that would say, how can we improve a city given its certain size of population or its aspirations or its trend in terms of population, maybe predict what might be the outcome of growth or shrinkage of a city. Which brings me to another collaborator we have down at Arizona State University, an economist who looked at also the 400 MSAs in the U.S. And these are 4 different quadrants where the richest cities are like this down here, and the poorest cities are like this up here. So let me explain what these bubbles are. They're color-coded by, it's from the Department of Labor, and there are 700 and something different occupation types. So these are color-coded by occupation, but and then the size of the bubble is how many people in those cities or in the U.S. work in that occupation. And the way that they're laid out, it's this artificial sort of like false coloring. This is false spatial. But the way they're laid out is they're clustered according to occupations that tend to be, that you tend to find in the same city. So in Hollywood, you would find a cluster of some of the creative arts that you wouldn't necessarily find that same cluster in Jackson, Mississippi, or Atlanta. And so you look at cities like New York City or Chicago, and the labor force isn't as diverse as some of these other cities, but it's concentrated around these creative, higher paying jobs. And so you can look at data like this if you're the mayor of some city, and you can say, well, here's my labor force, and here's like biotech right here. I got nobody in biotech. So probably it's not a good idea for our city to set ourselves up and try to invest a lot of money in becoming a biotech. You know, maybe we have the strength here that's in some other area, and maybe we should build up on that strength there. So this kind of data also allows cities to make these kind of maybe more educated decisions about themselves and their future. See, it's like 3 minutes to 8. I promise that the next several slides will be like really exciting. So if you let me go a few minutes extra, maybe 5 minutes extra, I want to tell you about a third project that we're doing. That's actually I think one of the more exciting ones, and that is with some of the folks that are here. Raj is here. By the way, Raj was on that that video at the beginning. We're talking over the screen and stuff. The funny thing about those videos, this is a total side, is that's called B-roll. And so it looked like we were talking about the circuit design stuff. I think we were talking about the Chicago Blackhawks or something. But since you didn't have sound, it looked like we were doing this technical conversation. So Raj and some others, we have a team here led by Pete Beckman and Raj, and another team at the School of the Art Institute of Chicago led by a professor there named Doug Pancoast. And we set out about 1.5 years ago to design a box that would have power and access to the internet and would be mounted on 500 street corners throughout the city of Chicago. Why? Because there are technologies that we want to try out, and there are data that we want to collect about cities that you can only get if you embed technology down in the city. And what we found as we tried to do this in an ad hoc way over the last few years with air quality sensors and other things is we found that there's just nowhere in the downtown of a major city that you can mount something in a place that's not going to get stolen, that's going to have power, and that will have internet access. So we went to the city of Chicago and said, imagine if we had this network of boxes. Imagine companies coming in and saying, we want to put something in here to try it out, like to control autonomous vehicles or a high-speed new kind of cellular connection communication mechanism. And if we've got these boxes on the street corners, we, the city of Chicago, are the place that you want to come if you're doing work in this kind of technology in cities. It also means if we've got microprocessors and storage and communication on street corners, you folks in high school can start to think, well, 5 years from now when my iPhone or Android device is 100 times faster than what I've got today, how might I interact with the city in a different way than I would if I didn't have embedded technology in the city? So let me close with one example of what that might look like. It's actually a project that we're hoping to do. You might recognize this up here if you have, how many people have like a Fitbit or a Jawbone or some other kind of device that you wear? Don't be shy. All right, so this one, it's my son Rich. He runs about 50 miles a week. This is not me. So this is steps that Rich takes in a particular week. That's interesting information. There are a lot of people that like to get that information. But imagine if you could get this graph over here that said, here's my exposure this past month to particulate matter, a really fine dust that gets in your lungs, or to volatile organics, or nitrogen dioxide, or carbon monoxide. Imagine if you could get that kind of graph. That'd be more interesting than steps, wouldn't it? Because that starts to impact over a long term my health. So over the next few years, working with the city, our plan is to blanket the city with these devices. They'll go out this winter with 17 different sensors: sound, light, vibration, infrared to get surface temperature, air temperature, humidity, precipitation, etc. Now imagine that you've got all these sensors on the street corners and they're telling you something about air quality. So red is bad and green is good and yellow is not so great but not terribly bad. And I've got this data about the city at maybe this is 4:25 in the afternoon. Our boxes, the sensor boxes, every 30 seconds will send all the data they collect to a server here at Argonne that will be open and free for anyone to grab that data either in real time or just keep grabbing it. The city is going to pull it into their data portal. So free, open data, that's the city wearing a Fitbit and telling you about its health, telling you about how many pedestrians are on the corner, or what the surface temperature is, or how the air quality is. Now you've got this And you can not only get now that graph I showed you before, but imagine you get something like this. It says, at 8 in the morning, I walked from Union Station over to the Chicago Architecture Foundation. Not too good exposure there, but around 1:45, I walked over to City Hall, or the Daily Center, and good air quality. And then I took the train. I would need to take the 5 o'clock train, so I walked across town at 4:20. I got some really bad exposure here. Because we have the air quality data for the whole city then, your app in your pocket can say, tomorrow, maybe you should take Washington instead of Madison, because on Madison, all the cars are going in the same direction, and they're stalled there, or they're sitting there emitting emissions, where Washington's one way in the other direction, and the traffic's moving. So I want to reduce my exposure, I might take a different route like that. So these are the kind of things you could do if the city could actually talk to you and tell you its health. The exciting thing about this project, by the way, you should go to the corner of Jackson and Michigan at the Chicago Architecture Foundation. It's this wonderful exhibit a number of us were involved in. It'll be until next September. It's been running since May. 3D model of the city. Our team, actually Bo, also on this project, one of our jacks of all trades, we project down onto this 3D printed model of the city so that we project from 6 different angles so we can individually color individual buildings according to, right now it's according to energy use or a few other variables. And then the array of things I just talked about is on this wall here. So you should go and visit that. And then I'll just close by saying, we're really excited about working with the city of Chicago. I've said to the management at the university and the laboratory, give me any scientist at the lab, give me any faculty member at the university for 10 minutes, and we together can find a really interesting research problem about cities. I'd say that to you guys who are thinking about what you're going to do after high school or what you're doing now as an undergraduate. If any of this is interesting to you, you don't have to change your major, because there'll be something really interesting in the thing that you already wanted to do where you can have a real impact. And that's just a map showing the cities that we're either already doing projects with or where we're in active conversations with those cities on projects that we might do together. We expect this map to have a lot more red dots by next year. So I'm going to close there, and I guess we'll have something like -4 minutes for question and answer.
We've got a few minutes. So we've got a couple of folks with microphones kind of wandering the audience here. Does anybody have any questions? Raise your hand if you got a question, and our trusty microphone people will bring them around to you.
How about right here?
Oh, there. Let's go down here first. Alex, right down here.
Maybe you could say your name and like what town you're from. Oh, excellent question. So the question is, in those boxes on street corners, how fast are those processors? And the answer is, I really don't know. I have to ask Raj. So I don't know the exact number. So they're slightly, I'd say, a little bit faster than what you have in a smartphone. And they're faster because they're actually these little processors that have four processors, we call them cores, 4 cores within them. And we'll have 3 of those in those boxes. So it's quite a bit of computing power there. It can do anything that your iPhone or Android phone could do, probably about as powerful as like a tablet computer. The cool thing about this project, though, what was your name, first name? Coleman. So the cool thing about this project, I'm from Naperville too, by the way, good town, is that the city has agreed every year to let us put new devices out there. And what's neat about that is that as processors get faster, we can put faster ones out there. That means that you might have an idea for a new kind of sensor, like you might want a sensor that sense pollen or mold that people are allergic to. But it'll take a while before you invent that, and we have it on the market, and it's cheap enough that we can put it here. But when it's available, we can put a new box out there with that pollen or mold sensor. So we get to upgrade this every year with new, faster processors and better sensors. Excellent question. There are a couple over here.
Hi, I'm Mike. I'm also from Naperville. You showed a plot of wages versus population and walking speed and whatnot. I'm sure there are many more. Do you know how well that holds up around the world, and especially in very fast developing places like China and India?
Oh, I'm so glad you asked that question, because that's a really important point. There are 1 billion people that live in slums in the world, and that number does not hold for Rio or Delhi. And this is actually one of the reasons that, at least me personally, that I'm really interested in cities, because these cities are growing really fast, and that graph, which shows what the developing or the developed world is like, is not what it's like in other countries. So that's a really good question, and actually and point. Other parts of that, other things would actually follow that curve, but not per capita GDP.
I think we've got time for like 2 more questions, so.
I know someone who thinks the city of Chicago is watching him and tracking him to try to pin something on him. What kind of protections do we have for that?
Thanks for asking that. So what kind of protections, especially like with these boxes on the street corners? How do we know that we're not tracking you? That's a question, right? Maybe. Yeah. So I wish I had good news here, but I don't. So the bad news is that on your smartphone, all sorts of data, you have this digital exhaust everywhere you go. All sorts of data is being collected by companies. When you hit that OK to use that new app, you're given permission to these companies to use your data. I don't want to make a statement positive or negative about this, just that it's a fact of life. There you go. So you have like an antique phone. So that's cool, except the phone company still knows where you are within about 100 meters, right? And they keep that information. So even with that old smartphone, there's data that's being that's accumulating about you. So we have to grapple with that from a societal point of view, and now, tonight we don't have time to do that. I'll say what we're doing, though, because our project, we thought really, really carefully about, are we doing anything that would increase your vulnerability as a person walking on the street, that would have a negative impact on your privacy, and we deliberately made some decisions that would stay away from that. As an example, I said that we would count the number of pedestrians on street corners. We could, technically speaking, also record the addresses of those phones, including yours. Well, not including yours, because you don't have Bluetooth or Wi-Fi, okay? Everyone else does, though, sorry. But we made the decision to program the devices to discard that address information, so that we wouldn't be, even though I don't know of a way to look up somebody's modem ID on their smartphone and find out who they are, we just elected to stay way far away from that. So if you go to the website, this website here, urbanccd.org, if you go there, it'll give you a link to the Array of Things project, and we've got a whole section in there about how we've thought about and engineered these systems to respect people's privacy and to actually prevent, even if we were to change our minds, to prevent us from making a change to that without going out physically and doing something on the box. So we've intentionally crippled some of those so that the boxes are incapable of doing this sort of surveillance.
One more question. We got time for one more question.
It's a beautiful map up here. Good work. Typically, municipalities don't have money to do anything. You talk to them about Wi-Fi or this or that. They say, go figure out how you're going to pay for it and come and do it. So I'm just wondering if you had any thoughts on that. And along those lines, a majority of the locations I'm looking at are third world countries that are suffering and don't have the infrastructure or the data, or have you given any thought to that from a futuristic perspective?
Yeah, we have. So just kind of maybe to summarize your question. So a lot of cities don't have money to do the open data, et cetera, et cetera. In fact, it's a little more challenging than that even. If you look at African countries and Indian countries, for example, they're never going to have an open data portal, at least not in the next, maybe never, but not for a long time. That's not the priority. The priority for them is to get basic services out to some of these settlements that are what we would call a favela or a slum, but people there would just call a poor neighborhood. They don't happen to own the land that they're on, but that's a priority for those cities, is to be able to meet those needs. And some, as you probably know, in some cities, that need is so great for the documented parts of the cities that there are these populations that people refer to as the invisible people, because the city refuses to acknowledge that there's a settlement there, because if they do legally acknowledge it, now they've got to bring utilities and stuff, and they don't have the money to do that. So we've thought about that. There's some problems that, we've thought about and that we can do things about, and others that are beyond what an urban scientist can do other than understand and work with those cities to try to figure out what solutions might be available to them. One way we've thought about it is in terms of a city like Chicago has a director of data analytics, a whole team of computer scientists to do this stuff. They've got people that take care of their data portal. That's pretty rare. Probably 50 cities in the US can do that, maybe 25. There are hundreds of more. So when we built, as an example, the Plenario platform, we did it on cloud services for two reasons. One, so that, like with San Francisco, another city could readily replicate it and do it cheaply and quickly. But the other is so that a smaller city, let's say Fort Wayne, Indiana, or Bloomington, Illinois, as if they would just do the work of publishing their data, we can then pull it into our system, and they can, in our system, use our tools to do their own data analytics. And a number of cities have expressed interest in that model. So we built it on cloud services because that would allow us to scale as the data gets larger and as the usage gets larger. It's a tougher problem with the developing world. Some of the folks at Santa Fe Institute, that graph of GDP that I showed, actually have some projects we're working on with them and Harvard University to look at data about poor neighborhoods in the developed world and compare that to data that's available about some of these settlements, in this case, Ghana and South Africa, to see if there are underlying characteristics of these neighborhoods, so that there might be something you could do in a neighborhood that would improve its economic vitality, and you could try it out in a developed country and then move that solution into a developing country. Or vice versa. There may be things that can be done in Africa that we can learn from and repeat on the south side of Chicago.